Good evening, everybody. Welcome to another episode of vBrownBag. This evening, we are very excited to have Mike Foley, and today we are going to be talking about what's new in vSphere 6.5, the security pieces. A couple of show notes, get in on the conversation. I'll be monitoring the Twitters at vBrownBag and hashtag vBrownBag, so if you have any questions, pop them in there, or if you're live in the audience, please feel free to submit questions using the question format. As I said previously, our guest this evening is Mike Foley. My name is Chris Williams, and Mike, take it away, sir.
All righty. I guess I got to share my screen, though, first. Huh?
Yep.
There we go.
You've got the con.
Okay, I have the con. So my name is Mike Foley. We're going to start off with what is probably the most frequently asked question that I get around vSphere security, and it's the subject is VM Escape. VM Escape is not the problem you're looking for. If you want more information, please go to vmescape.com. After that, I am not entertaining any VM Escape questions in this session. So, for those of you that know me, you know that's a touchy subject. All right, so we're going to dive into vSphere 6.5 security. We've got a few things to talk about. Let's get started. When we talk security from an IT, there's two players. There's the IT folks and the security guy. And the security guy really doesn't care very much what the IT guy's problem is. He just walks in and says, when do I get encryption? And then it's left to the IT guy to manage, how do I deal with that? I'm managing hundreds of hosts, thousands of VMs, and there's just the three of us, right? The last thing you really want as an IT person is a security snowflake. And what I mean by that is you don't want to say, oh yeah, we manage all of our VMs this way, except those ones that the security guy says needs to be encrypted or some other security thing applied to it. Once you start managing things uniquely in a virtualized environment, you lose the return on investment of managing things at scale. And if you have to do security at scale, you don't want everything to be a snowflake because you won't win. So VMware is looking at security differently than a number of other vendors. We're providing secure access, much better logging, secured infrastructure by ensuring what you want to boot actually boots, and then finally secure data with things like encryption, encryption at rest, encryption in flight. So we're looking to deliver comprehensive security in a way that makes security easy to manage. Now in this particular slide, you're seeing the VMs on top, and you're seeing all of these infrastructure-provided security services beneath. Why? Because do you do disaster recovery within a Windows VM? No, you use something like SRM to do disaster recovery. Do you do policy-based infrastructure governance, meaning automating tasks? Do you do that within the VM? No, you use something like vRealize automation. Do you really want to do encryption within the virtual machine? No, because you can see here on this graphic, it might be Linux, it might be Photon, it might be Windows, it might be AIX, who knows what the OS is. Do you really want to manage multiple types of encryption technologies? It just doesn't get easy once you start going things at scale. And finally, network security services. Who manages firewalls within each and every VM when you can just, at the infrastructure layer, using something like NSX, provide firewalling based solely on policy, so that if I dump a VM into a particular group, it just inherits the group firewall rather than having to modify each virtual machine. So the first part we're going to get into around vSphere 6.5 is our new enhanced logging. And this is something that personally has been very, very close to my heart for 10 years. When I first started getting involved with VMware, I noticed that the logs coming out of ESXi and out of vCenter were just terrible, right? if you look at the way we log things today in the 5.x and 6.0 time frame, if I make a change to a virtual machine, all I get is Mike Foley reconfigured that virtual machine. Okay, but what did Mike Foley change? Did he move the virtual machine from a protected network to the public internet network? Did he add an ISO file to that virtual machine? Did he add 2 gigabytes of memory to that virtual machine? Who knows? It doesn't tell you anything. But if you look in 6.5, now you see Mike reconfigured that virtual machine, and he moved it from the PCI vSwitch to the non-PCI vSwitch. Now, why is this important going forward? Because this type of data, as it goes downstream through syslog, this is vSphere event data, as this information goes downstream through syslog to syslog collectors like LogInsight or Splunk, or name your favorite syslog collector, those tools now have data that they can take action on. So in this particular example, maybe your logging solution sees that that a database VM has been moved off the PCI vSwitch onto a non-PCI vSwitch. It either can kick off a script that moves it back, or once that VM goes out of PCI compliance, maybe then it should be quarantined and a ticket is logged to ensure that everything is okay with that VM. Those are all downstream sorts of things, and that is really where having much better logging can really, really help. So here's a couple of examples we're going to show. One is I'm going to make some changes to a virtual machine, and you're going to see what the logs look like. So I'm going to right-click on this Finance DB machine, and I'm going to edit the storage policy, and I'm going to encrypt that virtual machine. And then I'm going to go into LogInsight and show you what the logs look like for that virtual machine that's just been encrypted. Now, rather than getting a VM reconfigure event, I'm getting the actual disk name that's been encrypted, the key manager that encrypted that, the key ID of that VM that's been done. And if I go into the events, that same exact data is now also in vCenter events. So you can see a very, very rich environment for the logging. One thing to take note, you do not have to turn on verbose logging. This is native VMware logging. So in this example here, I'm showing that PCI vSwitch. I'm moving a VM from the VM network to the PCI vSwitch, and you're going to see here as I refresh the screen what the setting was, VM network, and what the new setting is, PCI vSwitch. So as I was saying, you don't have to do anything extra. You just configure vCenter to send its log information out via syslog, and the vCenter events will just show up. This doesn't add any appreciable performance degradation or anything like that to vCenter, because vCenter has been writing this information into the vCenter database forever. All we're doing is just directing that data not only to the vCenter database as a vCenter event, but also out via syslog. So there's nothing really big there. So what if I take a user on vCenter and I modify what role that user has? That's a real concern for security people as they want to monitor what's being changed within the environment. So in this particular example, I'm taking the user Mike, and I am going to grant him the new role of No Cryptography Administrator. And you see down here the log says the role has changed from No Access to No Cryptography Administrator. That sort of data being fed into your logging solution also will work wonders when it comes time for auditing. So before we dive into VM encryption, if you want to put up 1 or 2 questions in the chat or in the Q&A, we can take a look there. Otherwise, we'll do a Q&A at the end. Don't see anything just yet.
And Twitters are clear.
All righty. So for VM encryption, we looked at VM encryption vastly different than some of the other folks in the industry are looking at VM encryption. We're going to manage VM encryption using storage policies. So all I have to do is apply a storage policy to a VM. That VM, that VM then becomes encrypted. The big thing we're looking at to protect here is not someone walking out the door with a box full of disks that they pulled off an array, because that's probably a little more difficult to do. It's the guy walking out the door with a USB stick or a couple of USB sticks, or a very small USB disk drive, just walking out the door with all of your IP and being able to run it elsewhere. So by encrypting a virtual machine the way we're doing it with storage policies, that makes it easy and scalable. There's absolutely no modification within the guest. You don't have to tweak anything in the guest. You don't have to monitor anything within the guest. It's completely VM agnostic, so it doesn't matter even what guest OS we're talking about. You have a Windows 2003 VM that you can't get rid of for another 2 years, you can encrypt that. It doesn't matter what data store the VM lives on. NFS, block storage, vSAN, doesn't matter. Doesn't matter what the hardware version of the virtual machine is, because all of the I/O coming out of the virtual machine is being encrypted within the hypervisor. This encrypts both the VMDK files and the virtual machine files. Each of those can be encrypted. I can even encrypt each VMDK of a VM using keys from a different key manager. Here's a real big differentiator over something like a BitLocker. There's no access to encryption keys by the guest. If I compromise the guest, I'm not going to be compromising the keys that are used to encrypt that guest, because the guest doesn't even know. And for encrypted VMs, all encrypted VMs will have full support for encrypted vMotion. So how does this all work? Well, first, you need a third-party key manager, a KMIP 1.1 compliant key manager. I'll be showing a list of the key managers that we're testing with today, and give you a hint on what might be coming later. So when I instantiate a VM and I apply the encryption policy, the VM gets an encryption key created by ESXI. We'll call that the data encryption key, or the DEC. That key, in turn, is then encrypted with a key from the key manager, which would be the key encryption key, or the KEK. So when I power on the encrypted VM, vCenter says to the key manager, hey, I have this VM, I need that, here's the key ID for that VM. The key manager sends the key to vCenter. vCenter never persists that key, never stores that key anywhere. It just passes that down to the host that the VM is running, and to every other host within an HA cluster. So each one of the hosts within the HA cluster now has the capability of decrypting the VM. Note that the I/O is coming out of the VM, hits the VM encryption module before it ever hits the storage layer within ESX. That's why it doesn't matter what type of storage we're running on, because the I/O is encrypted before it ever gets to that part of the hypervisor. So you'll notice within a VMX file, the DEC, or the data encryption key, is stored within the VMX file in an encrypted format, encrypted by the key encryption key, or the KEK. And how does vCenter know how to get the right key to start the encryption or decryption process? Well, if you look here under encryption.keysafe, you see KMS01/5. That is the key manager alias that is set up within vCenter, and the key ID of this particular VM. So vCenter reads that information, and that's what it sends to the KMS server as its request for, hey, KMS01, give me key number 5, and then injects that key into all hosts within the ESX cluster. So how simple is this from a UI standpoint? Really, this couldn't be simpler. You take a couple of, first your VMs have to be powered off. We recognize that's a limitation. We'll see what we can do about that. But your VM is powered off. You right-click on the VM, and you apply the storage policy. Notice that I'm doing this for both a Windows 2003 and a CentOS VM. Doesn't matter what the operating system is. It's completely agnostic. So once I apply that encryption policy, the VM reconfigure event happens and the disks are encrypted. Now here's a VM that's already encrypted, and I want to decrypt it. Well, that's relatively simple too, because I just edit the storage policy, and I change the storage policy to a storage policy that does not include, does not include encryption. So data store default in this example. Once I do that, the decryption of that disk then happens. And at that point, I can power on that virtual machine. Once those other VMs are encrypted, I can power them on, and off I go. So the big thing here, though, is do you really want to do everything within the GUI? What if you want to incorporate this into your existing PowerShell workflows or your existing PowerShell scripts? There's now a PowerShell for VM encryption module. There's a blog article on it on the vSphere blogs that I wrote a little bit ago. And it adds a whole bunch of new commandlets. So encryption is now as simple as get the VM name and then pipe it to enable VM encryption. Once that policy is applied, ESX generates the encryption key. That key, the key manager then encrypts that key with the key manager provides a key to encrypt that key, which now allows me the mobility of a VM to move from here to there. So what if I want to encrypt just the VM home objects and not the disks? That's relatively simple too. I can just apply the policy, enable VM encryption, select the policy, and then just say skip hard disks. What if I want to run a report? That could not be simpler. It's get VM and then just a couple of selections. So a selection of name and encrypted. And you'll see what disks are encrypted, what VMs are encrypted, and what VMs are not encrypted. I could add get VM pipe to select name, comma, encrypted, comma, KMS server, and I would get the KMS server name of that the VM is encrypted with. And finally, to decrypt a VM, like I showed in the GUI, it's just pipe the VM to disable VM encryption. One of the big things here is that there's a new role called No Cryptography Administrator. A full admin has the capability to do things like encrypt, decrypt, clone an encrypted VM, add new key servers, delete key servers, manage keys. Those are all very, very powerful permissions. So we came up with a new role called the No Cryptography Administrator. So if you are going to be using VM encryption, now might be a good time to figure out, do I really need to give these very powerful functions to every single one of my vSphere admins? Or should I maybe save full administrator for a subset of them and give everyone else no cryptography administrator? Because a no cryptography administrator can do power on, power off, boot, shutdown, vMotion, but they can't do things like encrypt or decrypt. They don't have access to the console of an encrypted virtual machine, which is very similar in concept to Microsoft shielded VMs. And there's no ability excuse me, there's no ability to download encrypted VMs. So that threat of someone walking out the door with a downloaded VM to go run somewhere else is not only mitigated by the fact that they can't even download the VM if there are no cryptography admin, but is also mitigated by the fact that if vCenter is not connected to that key manager that holds the KEK, they're not going to be able to power on that VM or open up that VM as well. So as we come near to the end of the VM encryption thing, please add your questions into Twitter or into the Q&A here within GoToMeeting. And to reiterate, the DEC, the data encryption key, uses an ESXI generated data encryption key. The algorithm is XTS AES 256, very, very strong. That protects the data. And then the key encryption key encrypts the DEC, or the data encryption key. The real big, go ahead.
I'm sorry. I was going to say we've got a couple of questions in the question field, but I'll be ready to field them when you're done. Sorry.
Okay. So why don't we just jump to the questions, because I just lost my thought. That's all right.
My apologies. You were talking about the KEK encrypting the DEC. The question from Dan is, does VM encryption work with linked clones or instant clones managed by Horizon or VRA?
Okay. So a linked clone will inherit the key of the parent VM, right? You're going to have to talk to the Horizon folks as to when they're going to be able to really start using this capability, because of the way they build VMs. With a lot of the new stuff that's come out in the past year or two, things are they are better equipped to handle answering those questions. What I will say is we're talking here about VM encryption, and every VM gets a unique key. So from a dedupe standpoint, that could have a serious impact, especially in a VDI instance. But what is now going out into beta very shortly is encrypted vSAN. And in encrypted vSAN, the data comes out of the I/O comes out of the VM, hits the vSAN layer where it's deduped and compressed, and then it is written to an encrypted data store, which is vSAN. Same encryption libraries, same DEC and KEK, only in that particular case the data store is encrypted with the DEC, and that key of the data store is then protected by the KEK. And if I was doing VDI, I would be looking more towards that type of solution because of the scalability of vSAN, the performance of vSAN, and the ease of management of vSAN. There's less to change from a Horizon standpoint, but ultimately what you're really going to want to do is have a conversation with the Horizon folks.
Okay, and a question from Graham is, can you move encrypted guests between clusters? How about between data centers?
So in that particular case, you cannot do something like a cross-center, a cross-vCenter move, but what you can do is do a cold move. So if I have vCenter A and vCenter B, and I have a whole bunch of VMs on vCenter A, remember that the key alias, the key manager alias, and the key ID is stored on a per VM basis. I can move those the encrypted VM files over to vCenter B and set up the trust relationship between vCenter B and the same key manager or set of replicating key managers using the same alias. In that particular case, I put KMS01, and I would be able to boot up those virtual machines. So let's say you have a major disaster. You can recover from that. SRM has support for storage-based policy moving for encrypted VMs, so that will work. There are some caveats that I have, I think, in the next slide, or in a couple of slides after key management. Hopefully that answers your question.
Yes, it did. Cool.
Okay. Okay, so for key management, to configure a key manager, you're going to go into vCenter, and you're going to add the key manager. Now, what I'm showing here, I really should have called the, we have what's called a key management cluster, and it's just a loose term of a list of key managers that are all replicating keys between each other, right? Because you don't want to have just one box managing all your keys. You really want to have one box here on-prem and another box here in my other data center or maybe in the cloud, and they're replicating keys. So you're going to create this key manager cluster alias, KMS01, and then you're going to add your list of key managers, maybe, and their IP addresses in that alias, so that if the first one is down, vCenter will try the next one, and so on. So I'm going to add that key manager, fill in all the information, and then the next thing I need to do is establish the trust between vCenter and the key manager. Now, all these key managers have different ways of establishing trusts. We support, I think, all of the different ways, and we are going through a certification program where the key manager vendors will come out with implementation guides that show you how to, which of these 4 selections to pick, and then go off and configure. So if you're using something like SafeNet, it has one way. Using something like Thales, that's another way. And then finally, if you're using something like HITRUST, it has a completely different way to establish that trust. And we support 4 different methods. So this is not a final support list of key managers. We support key management interoperability protocol 1.1. So we support Quintessence Labs, Thales, HITRUST, SafeNet, and Vormetric. And we do have a key management server program coming soon. We'll stay tuned for that. There is also going to be some rather interesting news from some key manager vendors in the not too distant future that I think everyone else will find really, really interesting. I cannot say anything more than that. Any questions on key management?
I think that you the question was going to be will it integrate with the AWS KMS management system,
which is not KMIP 1.1 compliant. So no.
Gotcha.
Right. Who knows if that'll change in the future? I don't know. That's a question for AWS. That's not to say you couldn't run one of those key managers in AWS.
Right.
So if you're looking for a disaster-tolerant type of environment. Right? So how do you back up and restore an encrypted VM? Well, SAN mode backups today are not supported. And that's because the SANs have no visibility, no capability of looking into the contents of the VMDK, right? What is supported is using the existing hot add method using the vSphere APIs. There's no API changes to the backup. A proxy VM that does the snap and then mounts the disk on locally and then backs up the data that's inside the disk. That VM itself must be encrypted because only encrypted VMs can mount encrypted disks. And then the username that's tied, that's in vCenter for that backup user has to have this new cryptographic operations.direct access permission. That gives that user the ability to see the contents of the encrypted VMDK. Now, it is now up to the backup vendor to then encrypt the contents that they are backing up, because their backup proxy VM sees all the data in the clear. So you'll see more over time the backup vendors really starting to figure out more and better ways to do this, but today it will just work. One thing to remember and to talk about your backup, with your backup vendors is how do you restore that VM. So obviously what you don't want to do is back up an encrypted VM, your backup vendor encrypts that VM, whatever way they do that, and then to restore that VM, they restore the VM into a VM in the clear and then turn around and apply an encryption policy. Because while that VM is in the clear, it's in the clear. Ideally, what the backup solution should do is create an encrypted VM and then restore the files into that encrypted VM so that everything is always in an encrypted state. Best practices and caveats: do not encrypt your vCenter and PSC VMs, because if they're encrypted and everything goes down, their vCenter is the one that is talking to the KMS to get keys, and if it's encrypted and it's powered off, it doesn't have the ability to power on. So don't encrypt your vCenter or your PSCs. What's not supported with VM encryption is suspend resume. Encrypting a VM with pre-existing snapshots, you can consolidate all your snapshots, and then you can then all your snapshots going forward would be encrypted. Memory snapshots are not supported. vSphere replication, serial parallel port, and content library are not supported. Encrypted vMotion. This is actually pretty cool. I've had a vigorous discussion with someone who disagrees vehemently with me about this, but that's okay because they're wrong and I'm right. You want to encrypt data. You want to encrypt data the closest you can to the data. And the way we're doing encrypted vMotion is encrypting before the data ever gets onto the wire. So it doesn't matter if the wire is encrypted. What you are concerned about is the data encrypted. Now there's three new settings. There's disabled, which would be a vMotion the way it's always been, unencrypted. Opportunistic says if I'm moving from 6.5 to 6.5, encrypt it. If I'm moving from 6.5 to, say, 6.0, which doesn't support it, well, just go ahead and do the vMotion in the clear. Required says if I try to move from 6.5 to 6.0, fail the vMotion, because I can only go 6.5 to 6.5. So how do we do this? Well, I set the encrypted vMotion to be required within the settings of the virtual machine. vCenter, I right-click on the VM and say Migrate. vCenter generates a one-time use 256-bit key and a 64-bit nonce. And you can think at a very high level, a nonce is very similar in concept to a counter. And then every single packet going over the network is encrypted with the key plus the nonce. And that key is another XTSAES 256-bit key. So that migration spec gets added, the key and the nonce get added to the migration spec. The migration spec gets put out to both hosts, and at that stage, all of the data going over the vMotion network is encrypted. All of our encryption is using AES-NI, which is a encryption instructions built into your Intel and AMD CPUs. So everyone always brings up the performance question. I'm actually very surprised that it hasn't popped up yet. Everyone always brings up the performance question. The performance of encryption is very dependent on a number of variables. How fast is your encryption engine within your CPU? If you're using a CPU from 5 years ago, it's not going to be as fast as one that's available today. How much I/O is your encrypted VM generating? How large is it? all of these things factor into performance. How fast is your I/O subsystem? We do have a performance white paper. If you search for VMware VM Encryption Performance, you'll find the white paper on our white paper list. It also touches on encrypted vMotion as well. There's a very low performance impact on modern CPUs for this. Back to PowerShell. It's one thing to be able to say, okay, I want to set all my VMs to be required, but what if I have 1,000 VMs? I could do a get VM, tiny, pipe that to set vMotion encryption config, and then provide the required setting. That's a function that was created by Brian Graff, who magically, as a PM, actually still writes code. Before we dive into Secure Boot for ESX and Secure Boot for VMs, any final questions on encryption?
Yes, question from Matt. Mike, is vVol or vSAN required for encryption features, or are these features supported on any other storage, i.e. NFS?
I believe I already answered that question. It is storage agnostic.
All right. And is the communication, Graham's question is the communication between the vCenter and the ESXi hosts encrypted?
It has always been encrypted.
All right, those are the two questions.
All righty. So, big question comes up to me all the time, especially people who are under regulations like PCI. They want to ensure that no files have changed on their hypervisor because PCI says you're supposed to do that. Okay, that's all fine, well, and good. So they're like, when do we get a tripwire agent for ESXi? Like, ESXi is not Linux, so we're not going to be running user code on there to do checksumming and all that sort of stuff. So what we've done for ESXi is taken the Secure Boot capability that's inherent in all modern systems today and gone one step beyond that. So what we really want to do is validate that you're only running signed code. And if you look at the way ESX is built, it's built with using a whole bunch of digitally signed packages called VIBs, or vSphere installation bundles. Files never leave the package. The file system looks inside the package, right? So the file system's looking inside the package. It's not pulling anything out of the package. So I only have to validate the package, not the contents of the package. So based on that, on existing hardware today, I have UEFI firmware. What's inside that UEFI firmware? A digital certificate. The bootloader, the bootloader is signed with a digital certificate that chains to the one that's in the firmware. The UEFI firmware validates the bootloader. With ESXi, the bootloader, now that it's valid, now validates the kernel. Okay, so bootloader is clean, kernel is clean. Now the next thing that runs is the Secure Boot verifier. And then that validates all VIBs within ESXi. Right? So I can be assured against a certificate that's living in the UEFI firmware that every single VIB is digitally signed. And I've already checked this with someone who does a lot of PCI work, who writes books on PCI, and he has validated that this meets the requirement for PCI and ensuring file integrity. So, okay, that's great, but what if I want to force the installation of an unsigned VIB? Maybe I get some drivers from a vendor, and those drivers aren't signed, right? If Secure Boot is enabled, you cannot install unsigned code. It just doesn't work. So if you do get drivers from a vendor and they say, oh yeah, well we'll sign them when it finally comes out, then you're going to have to run with Secure Boot disabled. And that is going to have to be a discussion you're going to have have with your security people. Don't call Mike Foley for that one. So if by chance you already have signed drivers and you turn on Secure Boot, you will end up with a PSOD, and it will tell you which driver, which VIB you need to remove. Secure Boot for virtual machines is very simple. So if I have a virtual machine that already has the EFI firmware, Secure Boot is check the box. Okay, great, but I want to check the box on all my Windows 10 VMs and turn on Secure Boot for them. I can loop through all those Windows 10 VMs and enable Secure Boot. So let's do a couple of quick demos on Secure Boot. The first one's going to be Secure Boot for virtual machines. So I have a Windows 10 VM. Secure Boot is not enabled, so I'll show that here in the settings. Secure Boot's not enabled. EFI firmware is. I'm going to shut the system. The first thing I'm going to do is validate via PowerShell within the VM that Secure Boot is not turned on. Thankfully, Windows provides a confirm Secure Boot UEFI, and you'll see that value is false. Shut down the Windows 10 VM, enable Secure Boot, and rerun that PowerShell. So I'm into VM options, check the Secure Boot box, boot up Windows 10, I'm sure vKitty is really enjoying this right now. And now if I run that same command again, you'll see that Secure Boot is now set to true. Okay. So Secure Boot for ESXI, I did not have some hardware that I could test that on, we'll say like a Dell server or something like that, that I could enable and disable Secure Boot. I just didn't have that capability. So what I ended up doing was running a ESX65 VM, and then running on that ESX65 VM another ESXi 65 VM. That way I would have all the capability of being able to turn on Secure Boot. So what you're seeing here is I have an ESXi VM, and the unsigned, I have Secure Boot turned on, and the unsigned VIB installation failed. Now I'm going to disable Secure Boot for this nested ESXi 65 VM. And I'm going to retry the unsigned VIB installation. Okay, great. That did it. Now I have this ProFTP daemon running. I'm going to turn Secure Boot back on, and here's where you're going to see the PSOD. And it tells you ProFTPD needs to be removed. That's all of the stuff I have for my session here. Bring the questions. I can even...
Very cool. Let's see. Nothing in the local QA board just yet. The Twitters. JM Lucien. Nope, that's not a question. More of a statement.
What was the statement?
Oh, he was actually responding back to a previous statement of his. Yeah, I saw question mark, so I thought that it was a question. He threw me off. It was a head fake. No, it looks like we're good. I think we are clear of questions, sir. Thank you very much.
All righty.
Cam Ready says hi.
All right. Yeah. So I think in just to kind of to wrap it up, security has finally become a thing, and it's up to us, VMware, to make IT a lot more successful in enabling security. And if we make it really, really difficult to quote-unquote do security, people will find ways around it. They always do. It's human nature. And, security is more than just an NSX environment. NSX is a fantastic product. It really does what it does extremely well. What I'm talking about is how does IT then secure what NSX is running on top of? And that's where I come into play. So if you have questions, hit me up on Twitter. I'll be happy to answer them. Unless they're VM Escape questions, then go to vmescape.com. And I really should put some ads on that website.
There's much traffic.
Yeah. And, that's it.
Cool. Awesome. Vic Camacho says, great job, Big Mike.
All right.
Cool. All right.